Hello and welcome to another video on solving simultaneous equations using the elimination method. Now the whole idea around this method is to eliminate one of the variables. So in the previous video, all of the examples I went through, we always subtracted one equation from the other. Now that is not always going to be the case. And in this video, with these three examples, I'm going to show you that we're not necessarily always going to subtract one equation from the other. And it all depends on what signs you've got in your equations. So if we focus on the first pair of equations, notice we've got 6a and 6a. And remember, the whole goal is to eliminate one of the variables. So how can we eliminate the a's from these equations? Well, in this scenario, we would subtract one equation from the other. Because notice, if we do 6a minus 6a, well, those will just cancel out. So let's just go through this first example to see what our solutions will be. So 6a minus 6a, that cancels out. 5b minus 3b, well, that gives us 2b. And that equals 22 minus 18 is 4. So if we divide both sides by 2, we've got b is equal to 2. So that's our first solution. And now we can just substitute this back into one of our equations. I'm going to choose the bottom equation. So we've got 6a plus 3b plus 3, and instead of b, we know that b is 2, so it's going to be 3 times 2, and that equals 18. So we've got 6a plus 3 times 2 is 6, equals 18. And now if we subtract 6 from both sides, we're left with 6a is equal to 12, and therefore a is equal to 2. So our two solutions are b equals 2 and a equals 2. Now if we look at this second pair of equations, we're going to try and eliminate the b's. Okay, but there's a difference between this example and this one over here, and that is to do with the signs. Notice we have different signs. So what I want you to think about is how can we eliminate the b's? And the method we can use is to, instead of subtracting one equation from the other, we are going to add the two equations together. And hopefully when I finish doing this, you will see that the b's will disappear. So let's do that. So on the left hand side, we've got 4a plus 6a. Well, that gives us 10a. And now we've got b plus negative b. Well, b plus negative b is 0. They just disappear, which is what we want. And now on the right hand side, we've got 18 plus 22, which gives us 40. So if we divide both sides by 10, we get a is equal to 4. So the difference between these two examples is because we had different signs, we added the equations together. Here we had the same sign, so we subtracted. Here we've got different signs, so we add. So let's just finish this one up. So we've got our value for a. Let's substitute that back into our top equation to work out the value for b. So we've got 4a, and we know that a is 4, so it's going to be 4 times 4 plus b equals 18. Well, 4 times 4 is 16, so 16 plus b equals 18. And now subtract 16 from both sides, we get b is equal to 2. So our solutions are a equals 4 and b equals 2. Now we've got one more. We've got one more pair of equations to look at. And in this one, we're going to eliminate the u's. So let's have a look at the u's here. And what I want you to think about again is how can we eliminate the u's? Are we going to add the two equations together, or are we going to subtract one equation from the other? Okay, and now the answer to that is we are going to subtract. And again, notice how the u's will disappear when I do this. So we've got negative 5u, subtract negative 5u. Now, when we're subtracting a negative, that is the same as adding. So what this reads as is negative 5u plus 5u, which is 0. So they do eliminate. So the u's will be eliminated. So now let's look at the w's. So we've got 3w subtract 5w. Well, we're left with negative 2w. And on the right hand side, we've got negative 14 subtract negative 10. Well, that's the same as negative 14 plus 10, which is negative 4. So now we've got negative 2w equals negative 4. If we divide both sides by negative 2, we get w is equal to 2. So we have found our answer for w. Now we can substitute this back into one of our equations, and let's choose the bottom equation. So we've got negative 5u plus 5w, and we know that w is 2, so it's going to be plus 5 times 2, and that equals negative 10. So we've got negative 5u, and now 5 times 2 is 10, plus 10 equals negative 10. Now if we subtract 10 from both sides, we're left with negative 5u is equal to negative 20. Now if we divide both sides by negative 5, we get u is equal to 4. So our solution is w equals 2 and u equals 4. Now I think there's an easy way to remember as to whether we add or subtract our equations. And I always like to say same sign subtract, different sign add. Okay, so it's over to you now. What I'd like you to do is see if you can solve these 3 pairs of simultaneous equations. And just to help you out here, I've put that little saying, same sign subtract, different signs add. Okay, so let's look at the first one. Actually, what I'm going to do is I'm going to look at all 3 just to first of all see whether we're going to add or subtract the equations. So I can see here that we've got plus 3y and minus 3y. So we have different signs. So I know that I'm going to add these 2 equations together. Here I've got negative 4a and positive 4a. So again, we've got different signs. So we're going to add these 2 equations together. And finally, over here, we've got 5y and 5y. So this time we have the same signs. So we're going to subtract. Okay, let's get going. So 3x plus 2x is 5x. Well, these will cancel out. And on the right-hand side, 18 minus 8 is 10. So we've got 5x equals 10. Therefore, x is equal to 2. So we've got our x value. Now let's substitute that back in. I'm going to choose the top equation. So it's going to be 3 times 2 plus 3y is equal to 18. Well, 3 times 2 is 6. So 6 plus 3y equals 18. And now let's subtract 6 from both sides. So we've got 3y is equal to 12. Therefore, y is equal to 4. So our answers are x equals 2 and y equals 4. Okay, so this one here, we're also going to add the 2 equations together. Negative 4a plus 4a is 0. 2b plus 4b is 6b. And negative 6 plus 36 is 30. So 6b equals 30. Therefore, b is equal to 5. So that's our value for b. Now let's use the bottom equation. I always like to use the ones without the negative signs if I can, just because I think it will be a bit easier. So we've got 4a plus 4b plus 4 times b. Well, b is 5. And that equals 36. So we've got 4a. 4 times 5 is 20. So plus 20 equals 36. Now if we subtract 20 from both sides, we're left with 4a equals 16. Therefore, a is equal to 4. So our answers are b equals 5 and a equals 4. Now the last one. This time we are going to subtract the equations. So 5x subtract 5x is 0. That works out quite nicely. 4y subtract 6y. And in this case, I'm actually going to subtract the top equation from the bottom equation. So it doesn't matter which way round we do it, as long as we're consistent. And the whole reason I'm doing that is because I'm not going to be left with any negative numbers. So 6y subtract 4y is 2y. And 34 subtract 26 is 8. So if you did do it the other way around, you'll be left with negative 2y equals negative 8. But then the solution would always be y equals 4. So whichever way around you do it, you should get y equals 4 as your answer. So let's substitute that back in. So let's use the top equation. So 5x plus 4 times y, or y is 4. And that equals 26. So we've got 5x plus 16 equals 26. Subtract 16 from both sides, we get 5x is equal to 10. And therefore x is equal to 2. So we've found our solutions. So hopefully you got on okay with that. And just remember that same signs, if you have the same signs, we subtract our equations. If we have different signs, we add our equations. In the next video, we're going to look at some more simultaneous equations, but this time the numbers in front of our variables will not be the same. So we're going to need to do a bit of manipulation first. Hopefully, I'll see you then. Take care.